Based on what we've done so far, let's hit topic 3, basic probability rules. So there'll be some definitions that we've actually defined earlier in this course, and then there'll be some new ones, some new basic probability rules. But let's pull, hopefully this page, some of the keys from the previous couple pages are pulled together in one place for you. So I won't spend a lot of time on these ones that say definitions recall because we've just done them in the last couple of pages. The sample space, S, of a random process is a set consisting of all possible outcomes. Remember, we have to list all of them to be complete. So that's sample space. An event is a collection of outcomes. We often show that with a capital letter. It's a subset of a sample space. Two events are mutually exclusive, which is also called disjoint, if they have no outcomes in common. In other words, if their intersection is the empty set or if they both cannot happen. Now, this is one I do want to spend a moment just going over a little bit more. Mutually exclusive. What are some examples of things that would be mutually exclusive? Well, let's start with an easy one. Where I'm standing or where I'm sitting right now, it is afternoon. Can it be morning in the same spot at the same time? No. Also, let's say it's day. It's right now, it's daytime where I am at this moment. Can it also be nighttime at this moment where I am at the same time? No. If you get an A in a class, can you also get an F for your final grade? No. Once you have an A, there are no other options. All right. So that's mutually exclusive. The probability of any outcome in a random process is the proportion of times. So we're looking at proportions. So we're going to do some dividing that the outcome would occur in a very large number of repetitions. So this is also called, we think of it as it's the relative frequency, when it'll happen. And remember, the star there is down here. What we saw earlier, that probabilities can be approximated through simulation, but we can also calculate them, the probabilities using mathematics and getting an exact value. In the case of equally likely outcomes, so each of the outcomes are equally likely, theoretical probabilities using exact mathematical analysis can be calculated by enumerating, in other words, listing the sample space, counting how many outcomes comprise the event of interest, then dividing that by the total number of outcomes in the sample space. And that'll give us our probability. So once again, we've already gone through this and we will be going through examples later on. Now, let's pull together some basic probability rules. We've already touched on a couple of these, but let's just make sure we've got them all in one place. For any event E, the probability that can happen, so remember this is the probability that E can happen, is between 0 and 1 inclusive. So the probability cannot be a negative number, and it also cannot be greater than 1. The probability that the sample space will happen overall, everything is in it, is 1, because S is that sample space. The complement rule we're going to use a lot, very powerful. For any event E, the probability that it doesn't occur is 1 minus the probability that it does occur, which makes sense. If you think about it, if we add up the probabilities of something occurring plus the probabilities of it not occurring, it has to total 1 because we want everything to be accounted for. Now let's suppose that we have two different events, E and F. There are some rules, and I would suggest before an exam, make sure you do a cheat sheet with these rules on them. We have the addition rule for disjoint events. Remember, disjoint events they don't have outcomes in common. So if we're interested in the probability of E or F, we can just add those two probabilities, individual probabilities together. Now, what if there is overlap and they're not disjoint, in other words? Will we use that general addition rule? The probability that E or F happens, we add the probabilities, but then we're going to take away the duplicate. And we'll see these in examples a little bit later on. And then finally, the multiplication rule for independent events. We haven't really talked about independence yet. We're going to start here. But it's the probability of two things happening, E and F, is you multiply the two probabilities together, the probability of E times the probability of F. Now, independent means that the outcome of one trial does not influence or change the outcome of another. And we're going to show examples of this later.